Hello and welcome to multiple object tracking in videos using OpenCV in Python video series. This is part one of this video series. In this particular part, we will be discussing how can we track a single object in a video. In the next part, however, we will be discussing how we can extend this single object tracking to track multiple objects in videos. Object tracking is really important in several areas in data science, particularly in video analysis. Sometimes it is really time consuming to detect object in every frame independently. And further, detecting object in every frame independently is not only, in most of the cases, not only inefficient, but also it loses the confidence that is provided by previous frames, the detections and trackings of the previous frames. So this object tracking is a workaround. It is really fast. And in several cases, when we really want to annotate a video, we want to detect a particular object or set of objects in video, it is okay to just initialize the object in the very first frame, and then the tracker will automatically track the object throughout the video. Obviously, there are certain caveats there, but in this particular video, we are going to, in this particular part, we are going to discuss single object tracking. The next part will extend this idea to for multiple objects in the same video. Just to motivate you about the problem, this is a video sequence. I've just taken this video sequence from YouTube, uploaded by, I guess, We Talk Football. In that video sequence, if you see, there are a lot of objects that are going on. I mean, this particular object, that object, football is an object. There are a lot of objects that are being interacting with each other. So what if we really want to track these objects? For example, by tracking, I mean I want to know this particular object is where in which frame. So the video is just a sequence of frames, sequence of images, and in each image, I really want my object of interest. For example, this referee in this green shirt, this particular object may be my object of interest, and I want to know its position, its bounding box in each frame. So let's see how OpenCV can help us in Python. So let's go for coding directly. So first of all, we need some packages to import. For example, import CV2. If you have not installed this, you have to install this OpenCV in Python, maybe on Anaconda prompt, and there are other ways as well. I have pre-installed this, so I have loaded it. There are so many trackers in OpenCV that are available. So for example, correlation-based tracker, KCF, boosting tracker, MIL tracker, training learning detector, TLD tracker, median flow, moose tracker, CSRT tracker. There are so many of those. Let's list all of those in a dictionary. So trackers, tracker list, or dictionary, tracker dictionary, dict is, let's say there are so many trackers, so let's list them. CSRD, that tracker, and the OpenCV function name is cv2.tracker CSRD _create. So we will see later on how to use this, but if we really want to use this CSRT tracker, we need this name and then a brackets to call this function to initialize the tracker. There are so many other trackers as well. For example, KCF, that tracker is initialized by cv2.tracker KCF _create. So that. Then we have, for example, boosting tracker, and that is again cv2.tracker boosting create. And then we have we have a list of several trackers. So let me list all of those. Whatever we want to use, we can use. There are situations when one tracker performs better over the other, and we will see in what kind of situations which tracker should be used. What are the recommendations? So cv2 dot tracker mil underscore create, and then we have this TLD tracker, which is again cv2 dot tracker TLD underscore create, and we have a couple of more trackers like median flow, which is cv2 dot tracker median flow underscore create. And then one last one is Moose, which is really fast tracker. This is cv2 dot tracker Moose create. So that's a list of trackers that are available. It is good to have this list. Just for example, whenever we need one of these trackers to be used, we can use this list. So for example, let's use this CRT tracker. So our tracker that we are going to use, let's initialize that tracker using this tr dictionary dict, and from this dictionary we are going to use, let's say, CSRT. That will bring this outcome, and then we need to call that this way. So if we, for example, want to call directly, we have to use like this cv2 dot tracker CSRT underscore create, and that initializes our tracker if we really want directly. But what happens here is this particular command will bring this string here, and then we have this parenthesis for this function call. So either way is fine. Yeah. So let's see, the tracker is initialized perfectly, fine. Let's now read the video that I just showed you in the slide. Let's read that video. So that's a video stream, or video, maybe video, is cv2 dot video capture. So and then we have to give the path for the video. So the video I have is located in D, and the name is multiple object tracker MP4. So that's the video. Let's see if the video is read properly. Yes, it is read properly. Now we read one frame of it just to get the bounding box, or initialize the bounding box, which we really want to track further. So let's say we have return value, or return value frame, and that is v.read. That will read the very first frame, and then what we do is we basically display that frame. So cv2 dot imshow, we first initialize some window. Let's say that's my window name, and in that window I really want this frame to be initialized. After showing this frame, I really want to draw a bounding box on the object of interest. So BB bounding box is cv2 dot select region of interest. That's a region of interest. On which window we are operating? This window. Remember this window. This is the name. This name, they must be same. This is for reference. And then this is the frame for which we are going to crop that. And then what we will do, we will initialize our tracker. We will initialize our tracker tracker.init with this frame and with this bounding box. So far the tracker will get initialized. So let's see. Let's run that and see where. Yeah. So here, let's say I want to initialize this object. So I just draw a bounding box on that, and then I press enter, and the object is being initialized. The tracker is initialized with this box. Now the goal of the tracker is to really track this over the video, which means we need this bounding box on this referee wherever the referee goes in the video. So let's write code for that. While true, because we are reading a lot of frames, return flag and frame, that is v.read. It will read the next frame. If not, return value. If it ends, if the stream ends, then simply break. Otherwise, just get the success and box by asking the tracker to update. So the tracker will update. On this frame, the tracker will give now the box. Previously, we defined a box, but now in every frame, the tracker is supposed to give us the box on this particular frame. Now what we do is, if we really find the box, then the success will return as true. Then what we do is we get that box and draw a rectangle draw the same kind of rectangle or the box on the image. Let's see. So for example, X, Y, W in height, width and height, that's the box. Int A for A in box. So this box will contain 4 numbers. So we will iterate over these 4 numbers one by one. These numbers might be in floating points, so we round them up. We basically get just the integer part, and this X is the top X coordinate of the top corner. This is the Y coordinate of the top corner. That's the width and height of the box. So once this is returned, we can call the function cv2.rectangle, and we can say, okay, on this particular frame with this X and Y and the next coordinate. So we have to give the X and Y of top corner and X and Y of the bottom left corner. So we can give X plus W, that's the corner of the other corner coordinate, and then Y plus H. That is, so basically this X, Y is the coordinates of the top left corner. These are the coordinates of the bottom left corner in image coordinates. Then we can give the color, in which color we really want to draw that. Maybe we want to draw that in red. So let's say this is the code for red, or maybe for green, or maybe there are several colors, and that's one parameter that we have to give. Now after that, we have to show this cv2.imshow frame, so that the image, so this will display the image and this will draw the rectangle on the image. We can wait for a particular key. If the video is longer and we want to quit this process of tracking, we may expect a user to press a key, and then we just stop our process if the video is really lengthy and we cannot wait till the end. So cv2.wait key. This is how many units of time you want to wait. So let's wait for this. And 0xff. What this means is I'm showing this right now. What this 0xff means. What happens is this cv2.wait key, it returns an integer of 32 bits, and this particular number is the hexadecimal representation of 1, 1, 1, all the 8 ones, 8-bit number with all ones. So when we take AND of this 8-bit this 32-bit integer with this, what happens is the only 8 bits of this 32 bits, they will remain, and those 8 bits, they are copied here. So that's basically a shortcut of getting the least significant 8 bits of this 32-bit integer, and because that's the value of the key that we really want, the Unicode, the integer in the Unicode. Then we check if this key, which is now an integer, is odd q. This odd q will return a Unicode integer, the representation in integer form of this character q. If this really is q, if you want to quit, then we will break. Otherwise, the loop will continue. So that's the basic setup. We are just close to our basic setup. So let's see what happened here. Yeah, so that's the basic setup. We are really close to now to finish this now. After this loop breaks, what we really want is we want to release the object. We want to release the video stream object, and we want to destroy all the windows. Destroy all windows. So yeah, so when we will run this code, the expectation is you will see a red bounding box on the referee. So let's see, let's run this object. Maybe we have this frame. Let's run this here. Oh, it has errors. What kind of errors are these? cv2.cv2 has no attribute weight key. Why is that? Wait, oh, this k is larger. This k is, yeah, this k is in uppercase. Yeah, so I guess it will work. So let's see. Oh, it should draw it in red color. It is drawing it in, oh, it's BGR. Yeah. So now you can see this is basically tracking this object. The same object is being tracked. We can run this again and again with certain maybe changings. For example, we can change the color to this. That may be a different color. Let's see what that color is, or maybe 100. This might be a different color. We can run this again. For example, this. Let's track this particular object now. Let's track this object. And then what we really do is we press that, and we can see that this object is being tracked in the video. Yeah. So yeah. So that's about object tracking in single video. The steps are really easy. By the way, I have used here CSRT tracker. There are several other trackers. Which tracker to use is really, I mean, it's problem dependent. Let me compare some of the trackers. The CSRT tracker is really accurate. It's much accurate but slow. This KCF is also good in accuracy, but its accuracy is relatively smaller than CSRT when the object moves quickly. This TLD has problem of false positives, although it can be used. Moose tracker, this is really fast. The tracker is really fast, but the problem is if the object is moving in a really quick pace, Moose will lose the track. So for example, let me show you an object that may that the Moose object may not capture very well. Let's see. So let me highlight this object, for example, this object, and yeah. So let me show you this here. The expectation is if this object will move fast, the moves tracker may lose. In this particular case, it works basically. But let's in several cases, the moves tracker, it loses. Maybe we can focus on some other object. That the point is, if the object moves fast, maybe the tracker just lose its track. So let's say, for example, this, and then so it just changes the track to referee. Although if you see CSRT, which is a little bit slow but really great in terms of accuracy. So let's see, for example, the same object. We draw the same object here, and so it is not losing its track. It's moving on. So it really depends upon what kind of what is your requirement in the problem that you're tracking. If efficiency is really a big deal for you, then you may go for moves with a little bit drawback in the accuracy. If the accuracy is a real goal for you and you can compromise on a little bit efficiency, then CSRT is a better choice, better recommendation. And the other classifiers, they have their own benefits and drawbacks whatsoever. So in this particular video, we learn how to track a single object in a video. In the next video, we will extend this knowledge to multiple objects. So what if we want to track, let's say, 3 or 4 or 5 objects in a video? How can we move? So in the next video, in the next part of this video series, we will see how can we extend this single object tracker to multiple objects. Hope to see you in the next video.